Hi guys, Dr. Justin Savi here, going through semester test 1, and we're looking at question 13. Now A asks us to disprove the following statement by providing a counterexample. For all integers n, if n is odd, then n minus 1 over 2 is odd. Because we want to disprove it by counterexample, we only have to find one example, one integer that is odd, that shows that the sentence is false. So we want an integer that is odd, so that n minus 1 over 2 is not odd. And a very simple counterexample, we can put n equal to 5. Then n minus 1 over 2 is equal to 5 minus 1 over 2 is equal to 4 over 2 is equal to 2, and 2 is clearly even, so it's not odd. And that's all you have to do, provide just one counterexample. Okay, it doesn't work for 3, it doesn't work for 7, but it works for a whole lot of values. We can find counterexamples to disprove this statement. Right, question B was a little bit more tricky, and a lot of you got very few marks here because you tried to prove this using an example. Okay, here we wanted to disprove by a counterexample, and we can do that because we've got a sentence that says for all this is true. We just have to find one example to show that it's not true. But here we're trying to prove something for all integers m. If m is even, then 3m plus 5 is odd. So you can't simply give one example where this is true. So what a lot of you did was said, okay, put m equal to 2, then 3m is equal to 6, plus 5 is 11, and 11 is odd. Yes, you proved it for m is equal to 2, but we're trying to prove it for all integers m, and we want a direct proof. So let's do that now. Okay, so m is even. That means that m can be written as 2 times some integer k. So it can be written as 2k for some integer k. How do we write integer k? Well, you either write integer k, or you can say k is an element of the integers. So we know that m is even, so m is equal to 2k. Now we want to show that 3m plus 5 is odd. How do we show that something is odd? Well, the definition of odd, this by the way is the definition of even. It can be written as 2k for some integer k. The definition of odd is that it can be written as 2k plus 1 for some integer k, or 2q plus 1 for some integer k. So we want to show that 3m plus 5 can be written as 2 times some integer plus 1. Now we know that m is 2k, so 3m plus 5 is equal to 3 times 2k plus 5, and if we just multiply that out, we get 6k plus 5. Now remember, we want 2 times some integer plus 1. So if we rewrite this as 6k plus 4, you'll see where this is going in a moment, plus 1, you can now see that this one here has a common factor of 2. Take out the 2, and it's 2 into 3k plus 2, all plus 1. Now k is an integer. That means 3 times k is an integer. That means 3k plus 2 is an integer. So we've expressed 3m plus 5 as 2 times some integer plus 1. So we just need to give a little justification of this, where 3k plus 2 is an integer because k is an integer, and therefore we conclude, this is the definition of odd, we conclude therefore 3m plus 5 is odd. Now some of you got part marks over here if you stopped and you explained that well, k, whether it's odd or even, if you multiply it by an even number you get an even number, and if you add an odd number to an even number you get an odd number, and you got some marks for that. This however is the formal proof, because here we use the definition of odd. Yes, this is true, but we could ask you to prove that. Prove that an even number plus an odd number is gives you an odd number. And you could do that proof, a direct proof, by doing something very similar to this, by starting with an even number definition, an odd number definition, and getting out to something that is also defined to be an odd number. Okay, not so tricky, but most of you lost marks here because you simply tried to use a proof by example, which you can't do when you're proving for all